Thanks for watching this 8th video in a series of work solutions for Edexcel GCSE Computer Science, helping you revise for Paper 1. So in this video we go through how to get to the answers for question 3a about network topologies, and then your challenge at the end is to read through question 3b, which is again about run length encoding like a previous question, but this time run length encoding to do with bitmap in images. So let's have a look again at question 3a and read through the question first of all. So a company produces black and white digital artwork, and an argument breaks out between the technicians over what the best type of computer network is, the best way to connect them together. So some people are saying a ring topology is better, other people are saying a bus topology is better. Very geeky argument. There's no right or wrong answer. But the thing that we need to do is be able to make a statement and explain that statement, why a ring might be better for 2 marks, and then the opposite, why a bus topology might be better than ring. So first of all, a topology just means the shape and structure of a network, how the nodes, and one node is just one computer, how the nodes, the computers are connected together. So I've just searched up the first image on Wikipedia to do with network topologies. There's some on here we don't have to worry about, so we don't need to worry about line or tree, but we do have to be aware of all of the others. So these 3, mesh, star, and fully connected mesh, so this is a partially connected mesh, aren't in this question, but it's worth revising them anyway. Network topologies, by the way, are quite hard to get excited about. They're not the most interesting topic, but they're nice and easy for examiners to put into an exam, so it's quite likely that they will come up. In this question, we're interested in a ring and a bus. All of these are to do with connecting computers together. Each green dot here represents one node, and one node is just a computer or a device. So let's start with a ring topology. The idea with a ring is a computer, a node, can only transmit data if it possesses a token. So a token is passed around from one computer to the next, and it says if you don't have anything to transmit, that's fine. If you do have any data you want to transmit, you send it now when you have that token. So let's say this computer wants to transmit, it waits for the token, and then it can send its data along to the next one. Now even if this node wanted to send data to this one over here, it would have to send its data to this one, and then this computer would have the token. It would then pass it along here, and the token would eventually get passed all the way around to where your data needed to go. So you can see it's quite slow. You're waiting for that token to be passed around the network. If one of these computers fails, as in it's not switched on, or there's something wrong with the network card or something like that, the whole network ceases to act because the token can't be passed around and the data can't be passed around. So it's not particularly resilient. But the one good thing about it is if 2 computers want to transmit at the same time, so this one and this one, there's no chance of data colliding, as in a node can only transmit data if it possesses a token, and only one computer can have that token. So there's no collisions, there's no times when 2 computers try to transmit data at the same time. So how does that compare to a bus topology? Well, a bus topology has one, think of it like a motorway, one really fast shared connection, and all of the nodes are connected to that one really fast wire. So it doesn't matter anymore, like it did in a ring topology, if one computer's broken, if a different computer wants to transmit data to another one, it doesn't matter if a third computer is broken, it would still work. But a problem with bus topology is if 2 computers want to transmit data at the same time, it's like 2 cars turning onto a motorway at the same time. There's a crash, and that data is corrupted, it's lost. Both computers will need to resend their data, and it's quite possible that as both of these nodes resend their data, the data will crash and collide again. So bus is really fast for a small amount of data, but as more and more data is transmitted on a bus, there are more and more collisions and it slows down. So how does that relate to the question? Let's have a look. So one reason why ring topology might be better than bus Well, it's not possible for any collisions, so 1 mark for making a statement, and then a 2nd mark for explaining it. There's no collisions because in a ring topology, nodes can only transmit when they have the token. This means it can cope with more network traffic. So remember, 2 marks here. If you'd written both of these, you'd get the 2 marks. Alternatively, you could have written this. A ring topology can cope with more network traffic, 1 mark, because data doesn't have to be resent if there's a collision, because there's no collisions, you can't collide, data can't collide in a ring topology. Or alternatively, it's potentially more secure because the data isn't always sent to all nodes, which is something we didn't mention before. If this computer wants to send data to this computer, that data is sent on the bus that every other computer could access. Whereas if this computer wants to send to this one, it would only get sent down here. So not a great example, but it's potentially true that you could argue it's more secure because data isn't always sent to all the other nodes. And you could argue that a ring is easier to install because there's no terminators. Well, what does that mean? On a bus, you have to have a special terminator at the end of each bus, which just stops the data bouncing back over the bus. You don't need that on a ring. You just connect a wire from one node to the next node. And you'll notice these tend to be quite short wires. Here you need one big long wire that all of the others connect to. So lots of opportunities to get those 2 marks. And you kind of want the opposite for this question. Why might a bus be better than a ring? So you could argue it's faster because you don't have to wait for the token in order to transmit. So let's say if this node wanted to transmit, but this computer had the token, you'd have to wait for the token to go all the way around until that computer could transmit. Whereas on a bus, you transmit as soon as you want to. So you could argue it's faster, but bear in mind, it's not always faster. If there's lots of traffic on a bus, it's going to grind to a halt because there's more collisions. So you could argue that faster cabling could be used in a bus because there's only one shared cable to invest in. So this cable might be longer, but you can spend more money in making it support faster transmission speeds, whereas here you've got arguably quite a lot of cable going around. You could say it's cheap as less cable is required, arguably. You could say it's easy to add new nodes, easy to add new computers without breaking existing connections. So here, it's easy to add another computer, you just wire it up like that, but you'd have to break the connections in order to do that. Here, it's also easy to add a new node, and you don't have to break the bus in order to add a new node. And you could argue it's more resilient because you don't need all of the nodes to be switched on all of the time. Remember, if this one is unplugged or switched off or breaks, all of the others can communicate. Whereas if this one is unplugged or breaks, the whole network fails. So remember, 2 marks, any one explanation, one statement, and then one explanation. As long as they're linked together and they're valid, gets you the 2 marks. Okay, so the next question is 3 part B. This is all about run length encoding, but also for bitmap images. So in this question, it's probably helpful to read it through and then you go away and remind yourself how run length encoding works. One of the black and white digital images is stored using, again, run length encoding. A 5 by 5 pixel image is encoded as 1B, 3W, blah, 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 blah. So here, 1B means 1 black. So this is 1 black pixel, 3 white pixels, 1, 2, 3, 1 black pixel, and then you've got to work out what the rest of it looks like. So recreate the image from this run length encoded data by shading the black pixels. The first row has been done for you. So we know that this bit is the first row. You have to work out what the rest of this run length encoded data looks like on this image. Okay, I hope this has been useful. Well done for your revising, and I'll talk you through what the answer is in the next video. Thank you.